So, for example, the position vector of a body at time t is given by r of t equals, I keep losing my place, 1 plus 2 cos pi t pi hat plus 2 sine pi t j hat. T is greater than or equal to 0. I went way too far across. Yep, that's right. So you look at it and you go, this looks like a circle. I've got the same amplitude across and up. It's going to be a circle. All you have to do is understand and use. So you can actually look at this and go, it's a circle, the centre is, the radius is. You don't have to go through all of this if you don't want to. But you can if you want to make sure. You can, because the question is going to ask you, determine the Cartesian equation or convert this to a Cartesian equation or something like that. Or maybe even sketch it. You are not required to go through all of this if you don't want to, but I wanted to show you so you can see why this works, how this happens. You can simply go, it's a circle. This is a circle, radius is 2, and the centre is, you can work out what the centre is. Not you, you've answered too many questions already.
I've answered like 2.
Yes, and they haven't answered enough. They haven't answered nearly as many as you have.
This was barely a question though.
Who else would like to know me the centre? Go on, have a go.
Is it -1, 0?
It's either 1 or -1 and 0.
Oh, 1.
It's actually just 1. It's the opposite of what we're used to. It's minus h, but up here it's h plus.
Right.
Because in the vector form, we go to 1 and then we add something. So that's the opposite of what we see in the Cartesian.
So they're both positive now? Or is it just
Yes,
h?
positive means up and right, yes. Well, that pin didn't last long.
That's so weird.
Can you write the Cartesian equation of this circle?
Mm-hmm.
Do it. Or you can wait a moment and I'll do it.
X minus 1 squared y squared equals 2 squared.
Don't forget the squared on the radius. If I was going to write it like this, I would just have a 2 here. But in Cartesian, it's squared. It's 4. And that's my Cartesian equation. What is the domain and range? Well, it's a circle. So it's going from this point, 2 left and 2 right, -1, 3, and the range is going from
-2, 2.
-2 to 2. Sketch it.
Sketch it.
You okay, Julia?
Yeah. The centre point is 1, 0.
It might
the
make more
radius-
sense if you sketch it.
If I have sketched if the radius is 4, isn't it? 5.
The radius is 2. The diameter is 4.
Right.
Diameter is 4, radius is 2. Yeah, it's a 4 here because it's 2 squared, but the
Yeah.
radius is 2. Centre is 1, 0, 1, 0, and the circle goes like that. And we can go 3, 1, 2, -1.
You could have just said the word water.
Negative, no.
You could go.
1.
He knew. He was
Oh.
smiling at me.
What?
On the diagram, indicate where the particle starts and which direction it goes.
Huh?
Indicate on your diagram where we start and which direction we go.
Oh, like our direction vector
Well,
and our radius?
T is positive,
Right.
starts at 0. When T is 0, where am I on this circle?
Either at a little below 2.
I think we're exactly at 2, aren't we?
Are we?
We're exactly here, right? If T is 0,
Oh, you just.
cos 0 is 1,
Yeah.
sine 0 is 0, so I'm actually starting here and going that way. As my T increases, that's the direction I'm going. If it's cos T, sine T, no negative signs, you're going right hand rule.
So it'd just be the top part of the graph.
No, it's going to keep going forever. It's going to go round and round and round and round and round and round, but it starts there and goes round.
What's the point of saying T0? T greater than or equal to 0?
Starting point.
So I know where it starts. There's another thing.
Why do you know where it starts?
Why do I need to know?
Yeah.
Because the question might ask me, after how long, at what value of T will it be when it reaches this point?
Okay.
Or things like that. Or, for example, what's the period of this motion?
2 pi.
How do I work out the period from this function?
It's
Anybody remember?
B, 2 pi over B.
2 pi over b. Period is 2 pi over.
Oh, I see.
Its period is 2.
Mm.
When t is 0, I'm here. When t is 1, I'm here. When t is 1.5, I'm down here. So you can work out where I am in that circle all the time.
Isn't it? No.
Ask.
You said the starting point is 2, but isn't it 3?
The starting point is 3, 0, yes.
Right.
2 over, yes. 2 across. Starts here, moves this way. After t equals 2, we get back to where we started. And we just keep going and going and going. Notice, this equation tells me more. The Cartesian equation just tells me it's a circle. But like we had when we did this last time, the parametric equation tells me more information. It also tells me where I am at any given point in time, all the way around. Let's try. So, for example, the question might say something like, describe the motion of the body. It starts at this point, it moves in circular motion, anti-clockwise, blah, 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 blah. Period of, just put all those things in. What if I say the vector position of a body at time t is given by? R of t is 2 cos t I hat plus sine t j hat. So just before I go on, a couple of things to watch for. This has cos and then sine, so it's the normal thing I'm doing. X has the cos and Y has the sine. If I swap the cos and sine around, I go sine t I hat, cos t j hat. How does that change the motion?
Anti-clockwise.
Definitely, it's going to go clockwise,
So
opposite direction.
it's going to go the other direction.
And where's it going to start?
On the left
If
side.
it's sine t, my x is going to start at 0.
Oh, yeah.
And my cos t over here, and cos 0 is 1, so I'm going to start at the top.
Wait, how do you know it's going the other way?
Not this one. I was going to write another one that went r of t equals sine t I hat plus cos t j hat.
Yeah, what about that makes it go the other way?
Because you're talking sine and cos around on the.
Because I've swapped these. Effectively, I've swapped x's and y's. Well, look what happens. R of 0, where do I start? Oh, so this supposed to, yeah, that's right. Where do I start? 0 I hat, 1 j hat.
Mhm.
Where am I after a little bit of time? Sine is now 1, cos is now 0.
Yeah.
So where have I gone? From here
To the other side.
to there.
Yeah.
Let me go again. That was meant to be an R. R of pi is going to be 0 again, negative 1 j hat.
Yeah.
I'm now down here. I'm now going clockwise. Back. If I put a minus sign in front of either of these things, actually here's where it'll turn up, or here, you have to think carefully. What's going to happen? Which direction am I going? All right. This one is not a circle. How do I know? Ben Nan, how do I know?
Because it's not.
Sorry?
How is it not a circle?
How do I know this is not a circle? It's an ellipse. How do I know?
Oh, because there's a 2 in that one and.
One has a 2 and one has a 1.
Yeah.
So it's an ellipse. You can just write ellipse. If you want to, you can go through this and go cos squared plus sine squared and rearrange them. You don't have to. You have to understand and use the equations. You don't have to be able to derive from one to the other, but you can if you want. Do you want me to show you, or are you happy just to go, it's an ellipse?
Show me.
Show you, okay. X, you don't have to do this, but you can. 2 cos t, oopsie, therefore cos t is x on 2, y is sine t, that was easy, cos squared t plus sine squared t equals 1, x on 2 squared plus y squared equals 1,
That's it.
x squared on 2 squared plus y squared on 1 squared, just to make it explicit. It's an ellipse. It matches the ellipse formula straight off the formula sheet. So, I've got my equation. Describe it. Like this. This is an ellipse.
Center 0, 0.
Center at the origin. Yep. Horizontal radius, if you like, or major semi-axis. There's lots of words you can use.
1.
Horizontal is 2. Vertical,
1.
I want to use the real word. Semi-axis. Semi-axis is 1. Semi because it's half. It's half the distance across. Sketch it. Two, 1, negative 2, negative 1. If I tell you 0 is less than or equal to, get the right one here, t is less than or equal to pi, how is the particle actually moving? How is this body actually moving? Don't answer. Let them think.
Repeat the question, sorry.
If I give you this domain for the parameter,
Mm-hmm.
describe the motion of this particle, this body, whatever it is. Where does it start? Which direction is it going? where does it stop? Well, 0, and it's just cos and sine, so there's no funny business. I'm starting here, including that point, I'm going this direction.
Yep. And that goes all the way to -2.
I'm going to stop when my angle is pi.
Yep.
Over here, all the way to there. I'm not actually going anywhere here. This particle only actually travels on this part up here. Make sense?